Today's lesson is on medians and altitudes of a triangle. First of all, a median is a segment that goes from a vertex to the midpoint of the opposite side. So this blue line here is a median. The altitude, also known as the height, goes from a vertex perpendicular to the opposite side. If we look here where all three medians meet, all three of these blue lines, is a point of concurrency, and that point is called the centroid. So point P right here is a centroid. More importantly, your centroid will always be inside of the triangle, whether you have an acute triangle, a right triangle, or an obtuse triangle. Concurrency of medians of a triangle. This theorem tells us that our centroid is 2/3 of the median from its vertex. So that means from C to P, that is 2/3, and then from P to E is going to be 1/3. 2/3 plus 1/3 will make a whole. If, for example, CE, this whole entire median right there, is 27, we want to know what is the length of CP and what is the length of PE. Well, if we split this median up into threes, we have 3 equal sections. So we take the length and we're going to divide it by 3. So each piece is going to be a length of 9. So we've got EP is 9, PC is split up into 9 and 9. Therefore, CP is going to be 18, and PE is going to be 9. A few more examples. In this case, if the length of FP is 6, what is the length of FC? Well, F to P is going to be split into 2 equal pieces, which makes the length of PC 3. So the whole entire thing, FC, is going to equal 9. 6 plus 3 equals 9. Number 2, HB, the entire length of this median is 36. What is the length of HP? Once again, we're going to take that entire median and split it into 3 equal pieces. So each of those pieces is going to be a length of 12. So from P to B is 12. From H to P, we will double that, so we get a length of 24. So the length of HP is 24. Last example, if AP is 8, what is the length of GP? Well, AP is 1/3, PG will be 2/3, so we double that, we get a length of 16 for GP. Altitude, once again, altitude goes from the vertex perpendicular to the opposite side. So for an acute triangle, we go from the vertex here. Oops. We're going to go straight down so that we're perpendicular to that opposite side. If you have a right triangle, those altitudes, 2 of them are the legs of the triangle. And those 2 legs are the legs that form the 90-degree angle. We notice this point at that 90 degree, that is our point of concurrency of the 3 altitudes. If you have an obtuse triangle, if we go from this vertex, we try and go perpendicular to the opposite side, that's not going to work. So what we have to do is take that line and go on the outside of the segment. we have to extend the opposite side so that we get our altitude. If we go from this other vertex over here, once again, we have to extend that opposite side so our altitude ends up outside again. From the obtuse angle, we go to the opposite side. We can go inside of the triangle. Now, where would all three of these altitudes meet? Well, we can extend each of those, and we end up with our point of concurrency on the outside of our triangle. I'll make this as close as possible. If we go back to the acute triangle, let's say it's more specifically an equilateral triangle, which means all three sides are going to be the same. That altitude is also considered the median. If this is a length of x, that other part is a length of x.